Okay, here we are with number 10 on our chapter 3 and 4 test review. This is a rational inequality. That means that we have a variable in the denominator of this rational expression, and we have an inequality sign. So we are going to have to go through the steps of solving this problem. The first thing that we want to do is we want to find our critical values, and we use our critical values to find our intervals. So the first critical value that we're going to find is we are going to solve this inequality. And the way that we solve this inequality, we're going to find our first x-intercept. So what I do is I take my numerator, which is x plus 1, and I am going to set that equal to 0, and that is going to give me my first critical value, which is x equals -1, and that is a solution. That is a solution. So that means that my graph of this would cross the x-axis at -1. That does not mean that I have to use a bracket there. When I plug -1 into this, I get a value. I get 0 over -5. That's not undefined. So when I find a solution to these rational inequalities, the solutions are okay to be part of my final answer. That means that -1 is an acceptable answer. So you have to be really careful with that. So whenever you set the numerator equal to 0, you get your x-intercept, and that is okay. The second thing that we're going to do to find our critical values is we are going to set the denominator equal to 0. And if we were graphing this, this would give me a vertical asymptote. So this is when my domain is limited. So when I set my denominator equal to 0, I get something that is undefined. When I get something that's undefined, that cannot be part of my final answer. So in no situation can the +4 be part of my final answer. So that's the difference between a solution and when you're using your vertical asymptote and you're determining your domain. Anything that makes the function undefined cannot be part of your final answer. So -1 could be, doesn't have to be, but it could be part of our final answer. +4 cannot be part of our final answer. So I always like to draw a number line because that helps me determine my intervals. So I'm going to draw my number line right here. I've got 0, okay, so I am going to put the 2 points on the number line. I've got -1, and remember, -1 is a solution, so that means my graph would cross the x-axis at -1, and then my undefined value is 4, and that, if I was graphing it, that's where an asymptote would be. So now I'm going to determine my intervals. My first interval would be this whole area right here, and that would be -∞ to -1. That's my first interval. Okay? So my second interval is between these two values right here. So that is -1 and +4. So I am going to make that my second interval. And my third interval is this area right here. So that is going to be +4 to infinity. Okay? So after I have determined my interval, I am going to do a test point. And you can pick any point as long as it's inside that interval. I'm going to pick -2 just because that's a pretty easy point to use, and it's within that interval of -∞ to -1. I could have used -3, I could have used -4, but I am going to use -2 just because that's a pretty simple number and it's closest to where my interval stops, which is at -1. So what I'm going to do now is I am going to go back to my original function, which is x plus 1 over x minus 4, and I am going to plug in negative 2. So let's do this in just a slightly different color so we can see what's going on. So I have negative 2 plus 1 over negative 2 minus 4, and that's less than or equal to 0. Negative 2 plus 1 is negative 1. Negative 2 minus 4 is negative 6. That negative over negative becomes a positive. And so I end up with 1 over 6 is less than or equal to 0. And that is a false statement. Okay? So 1/6 is not less than or equal to 0. So that is false right there. Okay. Now we are going to look at our second interval, which is negative 1 to 4. I'm going to pick 0. 0 is like my favorite number to pick, and any time that I can pick 0, I pick it. So that is the next test point that I'm going to do, is 0. So let's plug that in, and I'm going to do that right here. I'm going to say 0 plus 1 over 0 minus 4 is less than or equal to 0. And I'm left with 1 over negative 4 is less than or equal to 0. That is a true statement. So that means that that interval is going to be part of my solution. So my value here is negative 4, and that makes it true. So we will just keep that in mind, that that part of that interval, the negative 1 to positive 4, is going to be part of my solution. Now our last interval is 4 to infinity. So for this interval, I'm going to pick positive 5. So I am going to plug in positive 5 for x. So I'm going to say 5 plus 1 over 5 minus 4 is less than or equal to 0. 5 plus 1 is 6. 5 minus 4 is positive 1. And I am left with 6 is less than or equal to 0. And that is not true. That is a false statement. So what that means is both of these the two intervals where I get the false statements, I can go ahead and mark those out because neither one of those intervals is going to be part of my solution. Only this negative 1 and positive 4 interval. So I'm going to need to erase just a little bit of this so that we can get my final answer here. So I'm going to leave the intervals and I'm going to leave this information over here where we talked about the difference between a solution and a denominator. So I know that negative 1 to positive 4 is going to be part of my solution. I also know that I'm going to have some brackets that I'm going to use in this situation because of that equal to sign. So my original problem is less than or equal to. So I'm going to have some brackets. Many students look at this less than or equal to sign and then just put brackets around both of them. But we can't do that. So if I come back over here and I look at my solution, now I got my solution from setting my numerator equal to 0. So that means the graph crosses the x-axis at negative 1, and that is okay. So it is okay for negative 1 to be part of my final answer. So I'm going to put a bracket around negative 1. Now, we talked about the denominator. When I set the denominator equal to 0, I got 4 for my value of x. So if I plugged 4 into my original function, I would get a 0 on the denominator, and that is not allowed. When I plug 4 in, that makes this entire x plus 1 over x minus 4 undefined. So 4 cannot be part of my final answer because that is what makes it undefined. So I have to use a bracket there. So this interval, this negative 1, it's negative 1 to positive 4 with the bracket around negative 1 and the parenthesis around positive 4. This is the answer to my original question.